This is one of the most important patches of sky ever photographed. It covers a piece of the heavens you could hide behind a grain of sand held at arm's length. And buried inside it is a faint red smudge so small you would miss it completely if nobody circled it for you. That smudge is a galaxy called MOMI Z14. Its light left home more than 13 billion years ago, when the universe was only 280 million years old. In the current research packet, it is the most distant confirmed galaxy ever seen. And what scientists found inside that smudge is what changed the story. You might have heard that JWST broke the Big Bang. It did not. The Big Bang model is still the best explanation we have for how the universe began. Webb did something different. It made a part of cosmic history visible that had mostly been hidden from us. And when that early universe came into view, it looked faster, brighter, and chemically stranger than many simple models expected. To see why, start with the light itself. When the first galaxies formed, their young stars burned hot and poured out ultraviolet light, short, energetic wavelengths. But space has been expanding ever since. As space stretched, the light stretched with it. By the time that ultraviolet light crossed more than 13 billion years of expanding space and reached us, it had been pulled into the infrared, wavelengths our eyes cannot see, and Hubble could only partly reach. That is why JWST was built the way it was. Its mirror is 6.5 meters across. It is gold-coated to reflect infrared light, and it works cold, far from Earth, behind a sunshield the size of a tennis court, so faint heat does not drown out faint galaxies. Hubble could see some early galaxies. The farthest ones slipped out of its view. Webb catches the stretched light they left behind. So Webb stared at a well-studied patch of sky called the cosmos field and collected light for hundreds of hours. In the data, astronomers found MOM Z14. Then they used a spectrograph, an instrument that splits light into a rainbow of wavelengths, to measure how far that light had been stretched. The answer was a redshift of 14.44. That places the galaxy about 280 million years after the Big Bang. Here is what made it strange. MOM Z14 is small, only about 240 light-years across. You could fit hundreds of objects that size inside the Milky Way. But for something that tiny and that early, it is surprisingly bright. The universe was barely getting started, and this little object was already working like a compact star factory. That brightness is where the first wave of hype came from. If every bit of light came from ordinary stars, some early galaxies looked as if they had built too much too fast. But brightness and mass are not the same measurement. In some young galaxies, gas falling toward an early black hole can heat up and glow before it falls in. That adds light without adding the same amount of starlight. The light is real. The simple interpretation was too quick. The deeper surprise is the chemistry. When astronomers split MOM Z14's light into a spectrum, they found fingerprints from elements such as nitrogen, carbon, and oxygen. Those elements are not what the universe starts with. The Big Bang mainly gives you hydrogen and helium. Heavier elements have to be forged inside stars, then released when those stars die or shed their outer layers. Finding enriched gas this early means stars had already lived full lives, changed the gas around them, and left material for the next generation. At least one earlier generation of stars had come and gone before MOM Z14 looked the way Webb saw it. And MOM Z14 is part of a larger pattern. Another galaxy, JADE's GS-Z14-0, appears at nearly the same cosmic age. ALMA, a radio telescope array in Chile, detected oxygen in its gas, another sign that chemical enrichment was already underway. These are not modern spiral galaxies dropped into the infant universe. They are compact, bright, early star factories. Webb keeps showing that the first few 100 million years were more productive than the simplest expectations allowed. There is one more piece. These early galaxies did not sit in empty space. Around them was neutral hydrogen, a cosmic fog that absorbs ultraviolet light. For the universe to become transparent the way it is today, something had to strip electrons from that hydrogen and clear the fog. The leading candidates are the galaxies themselves. Each compact star factory blasts ultraviolet photons into nearby gas, carving a transparent bubble. As more galaxies form, more bubbles grow. They overlap, and the fog lifts. MOM Z14 may have been contributing to that process, with hints that some hydrogen nearby had already been cleared. So this is what JWST actually found. The early universe was not impossible. It was busier than we had clearly seen. Gas collapsed into compact star factories quickly. Massive stars burned fast and enriched the gas around them. Some early black holes may have added extra glow. And those first galaxies helped carve open the fog that once filled space. MOM Z14 is one frame of that story, the farthest confirmed frame in the current research packet, and a sign that every deeper Webb image is filling in a chapter we used to mostly imagine.